confession to make on behalf of every science teacher you've ever had. When you're in junior school, you're told that everything is made up of atoms, and that those are kind of the building blocks of the universe. And then you come to secondary school and you realise that that was a lie, because actually at the centre of the atom there's a thing called a nucleus, which has protons and neutrons in it. And you're given the impression, of course, that those are the smallest things in the universe. That is not true either. No! So, those smallest things, the protons and the neutrons, are not fundamental particles because they're made up of something else. And we call those things quarks. There are 6 quarks in total, up, down, strange, charm, top, bottom. If you don't know what a quark is, it don't matter, you've still got them. That's a lyric from a song on YouTube. The song's called Strange Charm, and I highly recommend that you watch it. Okay, moving on. So as well as 6 quarks, there are 6 leptons. The electron, the muon, the tau. And if you add the word neutrino to those 3 words, you get the other 3 leptons. All of these particles, all 12 together, are everything that makes up matter. And collectively, particles that make up matter, be they quarks or leptons, are known as fermions. Now, this picture of the building blocks of the universe isn't quite complete, because there are also 4 forces of nature: the strong nuclear force, the weak nuclear force, electromagnetism, and gravitation. And they are all allowed to happen, they're all mediated by gauge bosons. Okay? So the gluon is the gauge boson that allows the strong force to work. Right? It kind of glues the nucleus together against the strong force. The photon is the particle that allows the electromagnetic force to work. And W and Z bosons allow the weak nuclear force to work. And until 2013, this picture was almost complete. And finally it was completed with the discovery of the Higgs boson. This is the particle that gives things mass. Now this weird, slightly ugly arrangement is known as the Standard Model of particle physics. Okay, now I know what you're probably thinking, which is, oh, Mr. Balfour, are those all the really convoluted words we get to learn at the new higher course? Surely there must be more. Well, yes, there are. Let's start off with hadrons. So, the LHC, you'll probably have heard of, Particle Accelerator, stands for Large Hadron Collider. Large means big. Collider means smashing things together. And hadron, well, you probably don't know what hadron means. 2 things to know about hadrons. First of all, don't confuse the letters D and R, because that means something quite different. And secondly, hadrons are combinations of quarks. One type of combination is a baryon. So this is a type of hadron which has a triplet of quarks smooshed together. So for instance, a proton is a baryon because it's made up of an up, and a down quark. 3 quarks. Another category of hadron is called mesons. And mesons are a quark-antiquark pair. So for instance, a pion has an up quark and an anti-down quark, and that makes it a meson. Now, quite excited about this next bit because I'm pretty sure, I've just found a new particle that nobody else has discovered. And I'm going to call it the balfron, naturally. And a balfron consists of an up quark, an up quark, and an up quark. 3 quarks. Must be a baryon. In my mind, the balfron looks something like this. I'm not an artist, but I'm pretty sure it would have massive biceps and give it a wee six-pack, kind of menacing angry eyes. So that's what a balfron looks like. So I think I'm going to get in touch with the Nobel Committee for Physics and ask them to give me one of their prizes. In response to that, they could respond in one of 2 ways. Number 1, you are a genius, Mr. Balfour. Here's a Nobel Prize and the prize money and a whole lot of academic prestige. Number 2, they could respond and say, you're an idiot, go and read Higher Physics. Because actually Higher Physics forbids this. There are rules when you put quarks together. One of the most important being, the total charge has to add up to give -1, 0, or +1. So let's have a look at the proton. Does that work? Well, a proton has 2 up quarks, which have a charge of +2/3. So 2/3 + 2/3. It also has a down quark, which is a charge of -1/3. That all adds up to give me +1. Have a look at the pion. The pion is an up and an anti-down. So there's the 2/3 from the up quark. And an anti-down has an opposite charge to a down. So it has +3, which gives you +1. If we look at the balfron, it's got 3 up quarks, which would add together to give 6/3 + 2. So that means that the balfron can't exist. Now I know you're feeling, probably the only word to describe it is distraught about that. So to comfort yourself, why don't you, when the video finishes, go to YouTube and click on the film or type in Strange Charm and watch that video. It is probably the 2nd best song of all time, just behind Aerosmith's I Don't Want to Miss a Thing.